Right, everyone. Next, we are moving to the tutorial problems, like conventional problems in your syllabus. It is mentioned, so that's why it is. I will take 5 problems here. I will explain total entire concepts related to that. So here, the first problem. In this first problem, determine the time periods of the waveform having a frequencies of 25 Hz, 10 kHz and 20 megahertz. From the theory class, the frequency as well as time period both are inversely relation. T is equal to, you want to find out the time period, 1 by f. Okay, this is the formula. From that, 1 by f, 1 divided by 25, that it will be equivalent to 0.04 second. This is the first bit answer. Second, the time period, the frequency is equal to 10 kilohertz. Whatever the time period, 1 by 10k, that will be equivalent to 10 10 power minus 4 seconds. Is it okay? Next, third one, again t is equal to 20 megahertz. 20 mega, that means 10 power 6. It is a numerator, 10 power minus 6, that means 0.05 into 10 power minus 6. 10 power minus 6 nothing but a micro, that will be equivalent to 0.05 microseconds. So clear? This is about the first unit, problem solution. Look at your answers. These are the answers. Okay, next we are moving to the second question. In the second question, what will be the frequencies of the AC signal having a time period? In this case, they provided the time period. You need to find out the frequency. Okay, it is a reverse of that. F is equal to, option A, F is equal to 1 by T. Just 1 by 1 microsecond. That will be equivalent to 1 into 10 power 6 Hertz. That is a 1 megahertz is a frequency. The second bit. In the second bit, again f is equal to 1 by 50 nanoseconds. 1 by 50 nano is nothing but a 10 power minus 9. That will be equivalent to 20 megahertz. Next we are moving to the C. 50 milliseconds, that is a 50 into 10 power minus 3, that will be converted into 1 by 20 Hz is a frequency. Okay, so this is about the solution for this particular problem. Okay, next question number 3. In the question number 3, the angular frequency of a waveform is 10 pi radian per second. Find A, frequency, and B, time period. So let me consider A, frequency A. So here, it is given 100 pi radians. That means omega is given 100 pi. You know the formula for omega. Omega is equal to 2 pi f. Right. What is omega? 100 pi is equal to 2 pi f. From that, pi get cancelled. F is equal to 100 by 2. That will be equivalent to, what is a, here it is not 100, it is 1,000. I'm sorry, it is 1,000. 1,000 by 2, that will be equivalent to 500 Hz. Clear? So this is about the first bit. Coming to the second, B. In the second bit, you need to find out the time period. T is equal to 1 by f. So 1 by 500. That will be equivalent to 2 milliseconds. Okay. So this is a third problem solution. So, this type of numerical problems may come into the examination. So that's why I provided all the formulas in the theory class. Then I explain how exactly apply in the numerical. Okay. Next we are moving to the question number 4. In the question number 4, a sinusoidal waveform is given by, this is a sinusoidal waveform we have. So that I is equal to 10 sine 6284 t plus 10 degrees, right, amperes. So they are asking about, peak value, RMS value, frequency and time period. These are the parameters you want. So first one, peak value. The peak value is nothing but a maximum value, right? From this relation, I is equal to Im sine omega t plus theta. Yes or no? So from that, im value is 10 amperes. So compare these two. Okay, next coming to the RMS value. So RMS value, IRMS is equal to, for the, this is a sine wave. For sine wave, RMS value is equal to maximum value divided by root 2. That will be 10 by root 2. That will be equivalent to 7.07 amperes. 1 by root 2 is a 0.707. That multiply by 10, 7.07 amperes. Next we are moving to third bit, C. Frequency. You want to find out the frequency. So omega is given. From that, omega value is 6 to omega is equal to 6284, right? Whenever omega is equal to 6284, omega is nothing but 2 pi f is equal to 6284. F is equal to 6284 divided by 2 pi. That will be, frequency will be 1 kilohertz, 1000 hertz. Okay, that is a f value. In the fourth bit, last bit, time period t. Once you know frequency, you can find out the time period. T is equal to 1 by f, 1 by 1k. That will be equivalent to 1 millisecond. Okay, so this is about the problem number 4. And then we have a last problem, problem number 5. In the problem number 5, we have a two currents, the current 1 and current 2. Both are two currents we have. So in this both the currents, so we need to find out the phase difference as well as two current, which current is a lead. So here I is equal to Im sin omega t plus theta. Here theta value, the first case is 6 pi by 6, that is a 180 divided by 6, 30 degrees. That is a theta value. It is a plus sign is there, right? Next, theta 1 for example. Theta 2 is equal to pi divided by 4, that is a 180 by 4, that will be equivalent to 45. Okay, it is a negative. So they are asking about the phase difference. Phase difference, theta is equal to theta 1 minus theta 2. What is a theta 1? 30 minus theta 2 is a minus 45. That will be equivalent to 75 degrees. So 75 degrees of phase difference. This is the first bit. Coming to the second. In the second bit, which current is a lagging or which current is a leading? So initially we have a I1. For example, I will consider this is a waveform for I1. It is starting from 30 degrees. For example, 0. It is a 45, 90, 180, 270, 360 for example. So the waveform will be start after 30 degrees, right? So after 30 degrees means this is a waveform, for example. 30 degrees, every 30 degrees it is increases. Okay, this is the waveform. Next, another waveform is start from where minus 45 degrees. So minus 45 degrees means, so is 0. For example, this is a 30. Minus 45 means that here 30, here minus 45. So this particular waveform is starting from here. What is the phase angle in between? Phase angle in between 70 degrees. Which one is a lead? So current I1 is a lead compared to I2. So I1 is a leading. So answer is I1. Okay, this is about the explanation about tutorial problems. Thank you.